Hey everyone, welcome back to Geometry Made Simple. Today, we are going to explore a very interesting and useful properties of circles, the perpendicular from the center to a chord theorem, also called the chord bisection theorem. By the end of this video, you understand why this theorem works, how to prove it, and how to apply it to solve exam questions. Let's dive right in. The theorem states that the perpendicular drawn from the center of a circle to a chord bisects the chord. That means if you draw a straight line from the center that makes 90 degrees with a chord, that line divides the chord into two equal halves. So in this diagram, point C is the midpoint of chord AB, which means AC equal to CB. Let's prove it step by step using simple geometry. Draw a circle with center O and chord AB. Draw OC perpendicular to AB. Join OA and OB. Now in triangle OAC and OBC. OA equal to OB because they are radius of a circle. Also, OC equal to OC. They are common side to both triangle OAC and OBC, and both have a right angle OCA equal to angle OCB, which equal to 90 degrees. OCA equal to OCB. So by the right angle hypotenuse side congruency rule, the two triangles are congruent. Triangle OAC is congruent to triangle OBC. So AC equal to CB because corresponding sides of congruent triangles are equal. The converse of this theorem is also true. If a line from the center bisects a chord, then it must be perpendicular to the chord. What we are saying is that if AC equal to CB, therefore OC is perpendicular to AB. Let's consider this example. In a circle, a chord of length 10 cm is 4 cm away from the center. Find the radius of the circle. Solution. The given question can be represented by using this diagram. Our chord is of length 10 cm and the perpendicular bisects the chord. So we can say our AC is 5 and our CB is 5. So let us join OB. And also in the question, it is given to us that our chord is 4 centimeters away from the center, and this is our center. It means that our OC will be 4 centimeters. Now, and our radius is OB. Now, let us apply Pythagoras theorem in triangle OBC. OB square equal to OC square plus CB square. OB square equal to our OC is 4 centimeters, 4 square plus our CB 5 centimeters, 5 square. OB square equal to our 4 square is 16 plus our 5 square is 25. OB square equal to 16 plus 25 is going to give us 41. Let us square root both sides. Square root of OB square equal to square root of 41. This cancel this. OB equal to square root 41 centimeter, or approximately 6.4 centimeter. That is the radius of our circle. Let us quickly summarize. The perpendicular from the center to a chord bisect the chord. It means that if line OC is perpendicular to chord AB, our AC will be equal to CB. If a line from the center bisects a chord, it is perpendicular to it. If OC is perpendicular to AB, it follows that our AC will be equal to CB. If this lesson made circle geometry clearer, drop a like, share it with your classmates, and subscribe for more geometry made simple. Thank you.